Use the quotient rule to derive the derivative of cotangent x. Well, what is cotangent x? Cotangent x is the reciprocal of tangent, right? And so since tangent is sine over cosine, cotangent is cosine over sine, like so. And if my job is to find out the derivative of that using the quotient rule, then I'm going to label the numerator u and I'm going to label the denominator v. Because the quotient rule states that if I take the derivative of u over v, I'm going to find u prime v minus v prime u all over v squared. So what is the derivative of each of these parts? Well, u prime is going to be the derivative of cosine, which is negative sine, like so. V prime is going to be the derivative of regular sine, which is regular cosine. V squared is going to be sine squared, so sine squared x, like that. So let's put it all together. The derivative of cotangent, that's a cosine, that was a close one, that was a close one. The derivative of cotangent x is going to be u prime v, so negative sine x, times v, which is regular sine x, minus v prime u, so minus cos x, u, which is cosine, all over v squared, which is sine squared x, like so. Excuse me. Now, negative sine times regular sine is negative sine squared x, minus cosine times cosine is cos squared x, all over sine squared x. Now what I'm going to do is I'm going to factor out a negative 1 on the top. And I'm going to be left with sine squared x plus cos squared x. Now why in the blazes would I do that? Well, there's a Pythagorean identity that says that sine squared x plus cos squared x is just 1. So I get negative 1 times 1 up here over sine squared x. Negative 1 times 1, let me get out my calculator, is negative 1, so let's pull the negative out, and that leaves me with negative 1 over sine squared x. And if 1 over sine is cosecant, then 1 over sine squared is cosecant squared. So let me write that out. So when all is said and done, I know that looks a little bit sloppy, when all is said and done, the derivative of cotangent x is negative cosecant squared x. So not the prettiest looking thing in the world, certainly not, but the quotient rule gave it to us, and boy wasn't that a lot of fun.